Good evening, everyone. My name is Nuno, and today I'm going to talk about how Cadwell's pepper moth experiment played an important role in natural selection. First, about the history of the pepper moth experiment. As you can see, in the 19th century, factories in England emitted highly toxic industrial soot, blackening the white oak tree trunks, which were an important habitat for the pepper moth. This changed the advantageous colored camouflage from white to black, triggering natural selection and caused an increase in melanic variants. Bernard Cadwell, who was a famous entomologist in England, found this experiment interesting and started his research on it. About the hypothesis, Cadwell summarized that the advantageous mutant would increase its dominance in heredity, and he made a hypothesis based on Charles Darwin's theory of evolution. In the hypothesis, he mainly stated three things. In polluted forests, there should be a lot of dark moss than white moss, and in contrast, in unpolluted forests, there should be more white moss compared to black moss. And dark moss on white tree trunks are likely to be eaten by birds, and this reverse should also be true. About the experiment. Cadwell designed the experiment with a geneticist called Edmund Briscoe Ford, who was also interested in this experiment. He used a technique called marked release recapture, where they mark the target, release it, and after a few days, he recaptured it to see the results. In the experiment, to directly study the predation on moths, like this in the graph, light-colored moths were twice as likely to be eaten by birds in black forest, and in white forest, black-colored moths were twice as likely to be eaten than light-colored moths. He also tested the survival rate of moths, and after marking each type of moth, 2 days later, twice as many black moths were captured in polluted forests, stating that black moths would be able to survive at a higher rate than white moths in dark-colored environments. Finally, I'm going to talk about how this experiment played an important role in the field of natural selection. This experiment played an outstanding role in the field of biology, especially in the study of natural selection, for two main reasons. This experiment was the most diagrammatic example of industrial mechanism in the 19th century, and it also provided the first direct demonstrations of Charles Darwin's theory of evolution. However, because the pepper moth are the only species which exhibit industrial melanism, this experiment was a rare phenomenon that we can only experiment with these species. Because these issues in the experiment now receive less attention, it is becoming more difficult to research. In conclusion, like this, the pepper moth experiment was conducted by enormous amounts of evidence in plants, and was logically proven step by step, becoming one of the most successful experiments in the field of biology. We can say that the logical design of the experiment, numerous research and evidence, and a reasonable hypothesis led to the reason why this experiment became the role model for natural selection caused by human activities. These are my references. Thank you for listening.
Thank you very much, Jin.